In this video, we're going to be talking about velocity as a function of time graphs. And throughout the video, I want you to consider what we discussed in the previous two videos with the position as a function of time graph and look for commonalities. Let's start by looking at the vertical axis. Note that it is for velocity and our units meters per second. The horizontal axis, time, again, is in seconds. The moving man's initial starting position is at 0 meters. And throughout these 8 different segments, I want you to consider the areas where there's a positive slope, a negative slope, a slope of 0. Areas where we cross the x-axis. What does that mean? How do we see that motion in the moving man? And how can we relate that back to the position as a function of time graph? So let's go ahead and get started with segment 1, which is approximately 2 segments. And let's look what the moving man does here. And we see that he moves off to the right. He moves off to the right with a constant velocity of 2.5 meters per second. And we can see that graphically looking at the velocity time graph because the slope is 0. Well, recall in the position time, a slope 0 meant the object was stationary. Well, here slope 0 is has a positive value, and so we see that the man moves to the right at 2.5 meters per second. Then we see an abrupt change occurring at 2 seconds, and we see our line drop to the origin here of 0, right on the horizontal axis. Well, that corresponds with 0 meters per second. So the man will now remain stationary for approximately 2 seconds here before turning and moving back to the left. Now, what do you notice about where this man turns and moves back to the left? Well, we've dropped beneath the x-axis here. So we've gone beneath the horizontal axis. We are now looking at a negative velocity, i.e., the direction of the velocity is to the left now compared to segment 1. So this moving man is now going to move off to the left, have a negative velocity of negative 5 meters per second, or 5 meters per second to the left would describe his vector quantity for velocity. But guys, look at the magnitude for a moment. This is twice the magnitude of segment 1. That's very important to notice. Also note that I'm using the term magnitude. So the magnitude of velocity is speed. So I'm basically saying he's going at twice the speed that he was going in the first segment, even though the directions are opposite. So let's go ahead and look at that as the moving man moves to the left for 2 seconds at 5 meters per second. Then we get to another area where we are back along the horizontal axis, which corresponds to 0. So guys, anywhere this line is along that axis or crosses that axis, at that instant or for that duration of time, the object is stopped. That is a fact. So now we see for a duration of time, the moving man's going to hang out here. And again, notice moving man is to the left of the initial starting position. Now, between 8 and 10.5 seconds, we're going to see something different. Note we have a positive slope. Note that it is a constant positive slope, which means the speed or the velocity of the moving man is increasing, but at a constant rate. That's critical. So we're going to see the man's velocity increasing, but the rate at which it increases will remain constant, as you can see, because we have a constant positive slope. This corresponds to the man accelerating, because an increasing or changing velocity over time is by definition acceleration. So he will accelerate off to the right, get faster, 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 and here we're going to see another abrupt change. Now you might predict, the man's going to move immediately back to the left. That's incorrect. That's a common misconception. This man's velocity is still positive. All the way up until a little bit before 12 seconds, this man's velocity is positive. It is above the horizontal axis. That's positive. That means the man is moving to the right. You're probably thinking, well, there's a negative slope there. When we looked at position time graphs, the negative slope indicated the man was moving backwards. That's correct on a position time, but on a velocity time graph, the man is, or object is, moving in the opposite direction only once it has crossed the horizontal axis, like we saw in segment 3. So this man's rate of velocity is the velocity is decreasing, but at a constant rate. In other words, the man will slow down. The man slowed to a stop, now has turned around. Now we're going to drop beneath the horizontal axis, which means if we cross that axis, the object has stopped. If we're along the axis, the object is not moving. In this case here, it's just for an instant. We drop beneath the axis. Now the man will be moving off to the left between 12 seconds and 18 seconds, but at a much slower, constant velocity, as indicated by the fact that the slope for this duration is 0. However, the vector quantity is negative, which means he moved in the left direction, in the negative direction. And of course, for the final couple seconds here, we see a slope 0, yes, but we are along the 0 meters per second axis, which means the object, the moving man, is not moving for the final 2 seconds of this graph. Very good. Now what we're going to do is we're going to take a moment and really analyze what we can get from this graph and compare it not only to the position as a function of time graph, but also now looking at acceleration as a function of time graph and the significance of the area under these graphs as we continue to analyze motion graphically. So we're going to move on to the next segment here where we're analyzing this graph, and I will see you guys in class.